Cool. 437, path sum 3. You're given a binary tree in which each node contains an integer value. Find the number of paths that sum to a given value. The path does not need to start or end at the roof. I'm saying it weird. At the root or a leaf, but must go downward, traveling only from the parent nodes to the child nodes. The tree has no more than 1,000 nodes, and the values are in the range negative a million to 1 million. Okay. Um, I think this is actually, I mean, it's not quite knapsack, but there's knapsacky thing to it. Uh, yeah, I think so. I could be wrong. I mean, there are ways to represent it, but I think this is actually a knapsacky problem. Um, well, hmm, I mean, yeah, I mean, you could, I don't know if people, it's similar to a knapsack problem, but okay. Yeah, hmm. How do we want to do this? Doesn't have to go all the way. Oh, does not. It can start and end at a root or a leaf. Okay, but must go downwards. Uh, oh, it's the number of paths, not just. Okay. Hmm. Oh, this is easy. um, yeah, cool. Hmm. Maybe this isn't knapsack E though, but yeah, I think what you want to do. I mean, uh, yeah, is that for each node, store all the possible values that the sub the children or ancestors, no, the descendants can take, and that should be good enough. And we store it in a set. Well, it'll be a set with the number of paths, but right? I'm thinking about this one. How many nodes are there? 1,000. Mm, I would say usually, if you're giving the wave formulation, usually you do this thing in a knapsacky way, but the range from a million to negative a million to a million is a little odd, but maybe not. Uh, hmm. Yeah, should be okay. I think you just do it recursively and then just store all the things that are there, right? I mean, you earned that reputation. You earned one poster, right? I think definitely yeah, for easy problem, this is tricky. I mean, I don't. I think some of it is also what I'm a little skeptical about is like how strict the boundaries are respected. Definitely, definitely, I feel like you could do crazy enough things such that yeah, such that like you could really push around time limit exceeded stuff. But maybe I could do something naive. Okay. Hmm. I mean, I think at the root of it, no pun intended, is that at each uh, root node, you either use it or you either start or you don't, and then you kind of recursively go that way. I'm gonna just try to do some kind of memorization with that, kind of going along those lines. But okay, you have the root and the sum. Okay. Can I just use this directly? Okay. If now I need to kick something off of a kind of temporary value. I'm gonna try to do something with memorization, but I think I could optimize it, but I don't want to prematurely optimize that. But okay, so let's kick off. Some 0. So oh, I did name it the same thing. Whoops. Okay. Let's go this target, and then sum is probably more what I want. Okay, so there's two things here. Okay, if target is equal to sum, then yeah, I think so. So you could definitely cache that way. What I was thinking of, I was gonna just put the stuff on the node itself, to be honest. But we'll see how I play around with that. You could definitely hash on the pointers for sure. I mean, in most languages, I want to say. I mean, it depends on a lot of other things. But I mean, yeah, I mean, the object ID on other languages are kind of like a pointer, but not exactly. I guess it's like a reference. But yeah, let me get to that one. But you still want to possibly go down. Okay, so okay. So I'm going to just do a brute force with no memorization and then kind of go downwards. Because I think you could do some kind of magic to optimize this for sure. Okay, so use this node. So sum and no, do I need something like that? Because what I assume is okay. So this dictates that the path ends. Path ends here. So that's one of the possible things. I mean, the path could still end here, even if the target is not equal to sum, but then the return value is 0. So you add that into the sum or the number of counts. Okay, the path continues on with this node. Yeah, I guess I do need a maybe. I wouldn't say that. I think recursion is fine for the most part. I think if you're just going to say, and I'm doing this recursive, I'm going to end up doing this recursively. But I think if you're going to say, what was it? Yeah, if you as long as you kind of do your analysis to make sure that recursion is within like it doesn't get into stack overflows. It uses, and if you make sure that, for example, like if you're passing by reference in theory, that's probably fine because you actually push stuff in the stack. So it depends on how you allocate memory or what you're doing within the stack. I think it should be okay. Like if you're passing references in theory, that's okay. That's just going to be, just your stack depth times the constant number of things or something like that. I think as long as you, I mean, that's how I think about it. But certainly there's some people like, oh, now try to do this iteratively or something. I don't know. I mean, which is a thing, but that's not my opinion. And You could do whatever. I think you should just do whatever if it makes you comfortable to solve the problem, because problem solving is already hard enough, even with no restriction in general. Okay, the path continues on. Just okay. So what are you gonna do? Solve that. Oh, just have to check if root dot left is not none. And then okay. Um, and this is not helpful. I think this is a good base case, but yeah, I'm solving this on recursion. So yeah, uh, I mean, there might be some caching thing, but I'm definitely solving recursion to begin with. But this base case may be wrong though. So let me think about it for a second. No, that's why I added the started thing. Let me. Yeah. If started, then that means we may be able to simplify this later, but for now I'm going to just do it as brute force as possible, and then kind of I don't know, see what happens. The path ends here, and then also. If oh, I'm like confusing myself a little bit. So yeah, this is okay. Let's start with the not started one. Maybe that's what I should have done. Okay, so if we haven't started yet, then we can either choose this node or not. Choose this node or not. So then you could either, so count is equal to, so that, some target, gotta go left. Yeah. Oh, why did I choose sum and target? I think that's why I didn't need it. Well, but then it's just target minus dot wow, and then true, right? Okay. If root dot y is not none, then you do the same. Yeah, okay. And I think if with dot wow is equal to target, then well, it hasn't started yet, so because you don't want to double count it though. Okay, count one. So we have to do this actually. That's fine. I don't need this. Because once you end the path, no, okay. So if it hasn't started yet, then we could start a little later on. So, and we still need this either way. Now, we still need that either way for ending it. But if it hasn't started, then we have the option of going to, I guess you just this again. Well, then if that's not started, we have options of not using this and still return false. If we have started, I guess it doesn't matter if we started or not. We just but then we have to force to use this node as why something like that maybe. Yeah. Okay. Yeah, that was a little weird. I mean, we could definitely optimize that. I want to see if this works for this case, which should be small enough. 17. Oh, some of this is none. Oh, I didn't return count. Okay. I mean, it's returning an answer, which is probably off by one, but that's fine. At least, I mean, it's reasonable. But, this is for if it ends here, but you could still go on. Yeah, I think this is right-ish. Yeah. But, we could actually probably recursively start. But okay, I mean, I think this is okay. We could write it on DFS to start at a different node, but I think that's essentially what we end up doing anyway. I copy and paste terribly. That's probably why the answer was wrong. But okay, so that works. Okay, so I'm happy about that. I'm not gonna submit yet because, well, just not really confident about the performance issue. Let's think about what this is. For each node, we either count it or we don't. There's two of these, and these are all the roots. And it's count the number of paths. Yeah, I mean, we could do something like, we could cache it for sure. Which is self.cache.add. I just put target, started, and that is count, right? That's the tuple that I want. If self.cache, this tuple, which I would call as a key, is equal to this. If key is in cache, we return hash key. Otherwise, how does that sound? Well, let's see if that works for us. Oh. And that's what happens when you keep on bouncing back and forth between languages. I need to just stick with one. Okay. Is this fast enough though? I guess it depends on a lot of stuff. I don't, and this is, I think the annoying thing about these 3-year string, for me anyway, is that it's very hard to write out like a good example. But I guess I'll just copy the same thing and then choose other numbers, at least as a base case. Like some maybe, yeah, but I don't know. Let's at least kind of make sure this works, and then yeah. But I worry more about the bigger case than this. Okay, well we'll see. I don't know. One time I will. Oh, okay, fine. I didn't consider empty trees as. Is that really a rotted thing? Is it an empty tree? I guess so. Man, is that a real test case? Okay, fine. That seems like a. I mean, okay. I feel like that is not a fair one, but okay, fine. Um, but maybe I should have checked it. It's good. Okay. Hmm. Definitely just a lot of memory. I wonder if that's even. I mean, it is faster than half. How do I feel about this? I think my biggest problem with this one, to be honest, is that I mean, this is okay. I probably could have done faster. How long did it take? About 20 minutes, which for easy is, I think it's a little bit long time on my end. So I definitely could have done better. I mean, one of my, and this is something that, I mean, that's, hmm, 'cause I think use, you could construct a test case such that, it really pushes this to the limit more. So I think like, um, I think that's the part of my issue is that when you look at these bounds, and like in theory, there is probably like a bad case in which my thing times out, and I wouldn't be surprised. And I was just kind of going on a little bit of gut to kind of trust that is good enough. But that's why I heard about these bounds because if you don't really need all this bound, then like tighten it up, right, for a problem so that people can kind of make the right judgment call. Like if you're gonna make these numbers so varied and then not do all of it, then I don't know. It's a little weird. Don't know how I feel about it. Um, uh, there's an element of the subset that sums to a number. Um, you mean for this one? Oh, yeah. I mean, I think. I mean, I did do 550%. I don't know, but there is. So you could definitely use like partial sum, right? I don't know if you're familiar with partial sums. It's when in the 1D in a one-dimensional array thing, it's just like you like a prefix something, um, and then the to get the what's it called subset sum is just the difference between like all the children and like the parent or the node that you like like you store values at the nodes and then um, the sum of those paths is from then. And actually, I think in this way, maybe there's a clever way to do that. And I mean, there's definitely a better, cleverer way to do it. Maybe I spoke a little too soon on the. I feel like this should have failed though, if that's the case. But if you do that, you could actually looking at the tree instead of at the root first. You kind of see the root almost like an actual tree where it's going upwards, and on the bottom you store 10, and on for example here you store 15, which is all the sum from 10 or from root to here. Here you store 17. Here you store what's it 18. And then the difference between here is that this is 15 and this is 18. So then that allows you to calculate the subset sum that way. So I think you could definitely do something like that. I mean that allows you to bound things up a little bit better, I suppose, because then you store one thing on each node, and then it's just n. Hmm, yeah, and then I don't know. I mean, the way I was thinking about it, if that's the case, then you have n square pairings. So that is also what's n? N is 1,000. So that I guess that actually makes it a great time. That makes it a great dynamic program problem. I think, yeah. I mean, I think that's how you would solve it. Maybe that is a better way. What do you think? Should I just code it up? I feel like this should have failed. Then I hmm, maybe the caching made it good because it depends. Because there's still only I think maybe the caching makes it good because I think there's only n square possible sums, but is that true? Hmm. Yeah, I don't know. Hmm. How does this look in? Hmm. Yeah, okay. But yeah, I would say I don't. Still, like you said, a very hard, easy problem. I think yeah, I think I would expect to see this on an interview, but not necessarily the dynamic programming optimization. I think just like someone else pointed out, like just a recursion thing. I think this is a, maybe that's why it's easy is that because recursion works. I don't know if cache is needed, but I did it anyway. Um, uh, yeah, because I guess all I did is also just check the n square things because at each root it begins and then it paths out, but it's still each node only gets looked at n times at most. So even though this looks very ugly and looks maybe exponential, it actually should be n square. Hmm. Yeah, okay. I mean, I think the analysis is still the same, but I think definitely you have saved some time on the subset sum maybe. I'll have to take a look at it later. But yeah, thanks for the link posted, Rad. Definitely have fun. Did I mention about that problem? Okay, I guess I'm finished talking about that problem. Yeah, I think definitely just recursion itself. I definitely expect to see this on an interview, so maybe that's why it's easy. And I think that's definitely something people would do about. I'll have to look up the optimization, maybe learn a little bit about it later. And that's why I'm practicing dynamic programming. But I think overall this is okay. Took a little bit of time though. I think if I was just going to do it recursively, I should have done it faster. So, um, mm, yeah, okay. I think it took me a little bit of time to get this started variable. I think once I had this, I think that became easier. I just kind of was hoping to go without it. Okay, and another dimension or whatever.